friends, MoNaCo here.
And Milks.
We are in our third video on the periodic table. Last one was real short. This one's we're making up for it in this one.
Well, a little bit.
A little bit. A lot of information on pages 7 and 8.
Yeah, so really pay close attention and take your time. Pause if you got to deal with it.
Color code if you got to deal with
Right.
it. I mean, we love looking at nice things when we're grading these stuff, so make it easy on our eyes, and we'll make it easy on your grade.
There you go.
We're talking about specialized names and properties of
Each group and family in the periodic table, they have a name. We got to know them. There's some tricks to remember them, but we're going to do them.
and the properties too.
And I know you're limited on space, so even bulleted for you a little bit so you can conserve, right?
Yeah, and paraphrase. You know, take what we're
Paraphrase.
saying and simplify it so that you have something succinct, which is simple.
Yeah,
to study
I like to think about it this way. If you can't read it
and
and
understand.
it later, like when you're studying for the test, then what's the point?
Right.
The only thing is you can't lose the information or screw up the information when you write it in your own
You
words.
got to retain as we gain. As we
That's right.
gain new knowledge and information, you got to retain what we did before and work ahead with this unit pack.
There you
I mean,
go.
There's no need to scramble and cram.
No.
That's what studying
but-
is for.
And you're going to find a lot of the practice is quick in this, so we might do practice for like 3 homeworks in one day. And
Right.
if you haven't even done the first one, it's tough.
Yeah, you got to do this outside of class. So
Yeah.
the first group that we're talking about is got a special name called the alkali metals family. Alkali metals.
Group 1, you see it there highlighted on the left. Everybody's going to have one valence electron, makes them very unique.
Yep. They easily lose that one electron to become positive one ions, which is why for the selected oxidation states on our periodic tables, everybody's got a +1 in the top right corner.
Right.
Mhm.
Right.
Cool.
Yep, they are extremely reactive, especially with water. So they're never really found alone. They are always in a compound of some sort
Right.
in nature.
So never really found pure in nature.
Right.
Right. Alone.
Well, that's
pure,
what it's. That's
right,
I think that's
yeah.
what alone means there, right?
That's what it implies. Just clarify.
Yep, we should definitely clarify. Make
Yeah,
meaning.
very reactive stuff. Always found in compounds or minerals or rocks or whatever.
Right.
This group contains the most reactive metal. It's probably francium, Fr, but it's so rare we've got to go with cesium is our normally most reactive metal. And the way
So
the
what do you-
question
what
is
do you mean-
asked on
What do
the
you mean by rare?
rare, it's super rare because it's so reactive that you can't really like get a pure sample of it.
Right, because it doesn't stay around long enough.
No.
It reacts instantly with the water in the air even.
Yeah, you get a milligram of francium. By the time you have your milligram of francium, it's not francium anymore. It's like francium oxide or hydride, or it's
Right.
reacted. Yep, and done its thing. So the way how do they ask this question on the Regents exam?
They usually just say where on the periodic table is the most reactive metal.
And you would say
Lower.
bottom left.
Bottom left-hand corner.
Okay.
Right.
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 Cool.
Good. Good.
Thanks.
Next one, alkali earth. Alkaline earth metals is group 2. Okay, so they all have 2 valence electrons.
Yep. Straight down the stack.
They prefer to lose their 2 electrons to become +2 ions.
Which on our periodic tables are identified as a +2 in the selected oxidation
Sure.
state.
And they also, of course, have that 2 valence electrons.
To lose.
Right. And the whole reason why that preferred thing comes up, and it's a little bit more info, but, right, think about the octet rule that we're about to learn. We want 8 valence electrons, man. And what's easier to do, lose 2 or gain 6?
Yeah, let's
So it
not get too
prefers.
far ahead on that
Yeah,
stuff
well,
because
sometimes
that's
I
some
just do
chemical bond.
I just do that sometimes.
Yeah. These are fairly reactive. They are also never found in their pure state in nature. You can't go find a chunk of beryllium or calcium or strontium or barium out on the ground. It doesn't happen, not like a nugget of gold is. They're found in chemical compounds and minerals. They make nice, useful things, but we have to purify the element out of the compound in order to get it pure.
Right, so we can work on it and study its properties.
Exactly. Group 2, 2 words, alkaline earth.
Great way to remember the 2.
Group 2, 2 valence, 2 words, alkaline earth. Now, this is my personal favorite chunk of the periodic table because it's got most of the elements in it, but it's doesn't have much information. I mean, we don't have to know too much about these. So.
No.
Groups 3 through 12 are called the transition metals. The reason why they're called transition metals is because they're all metals. But in this particular piece of the periodic table, we're going to be transitioning from metallic character to non-metallic character. So they're transitioning. They're bringing you from the left to the right. Transition.
There's a little bit of variability.
Yeah. They're found in the middle.
They form colored ions in solution. For example, like copper is a bright blue when it's dissolved in water. And this concept is almost always represented in the Regents exam.
And it says, which one of the following elements makes colorful ions when in solution?
It's exactly the question they would ask.
All you have to do is pick the one that belongs with the transition metal,
Right.
like the nickel, the copper, the cobalt, whatever it was. Whichever one belongs in the middle of the table, there's your answer.
You can decode that question to say, do you know the definition of transition metals?
They make really colorful crystals too when they're in compounds,
Right.
if they're in compound.
Right.
They tend to be unpredictable because of the quantum nature of electron orbitals that we don't have to teach and we don't go into. They tend to be unpredictable, so they'll either lose or gain electrons depending on what other metals are present. So it depends on like what other element they come into contact. They're going to decide, am I going to give you an electron? I'm going to take one of yours.
Yeah.
They're variable.
And that's like 3 or 4 videos from now when we start to get into the terminology of who wants to get rid of electrons and how much. So we'll get into that.
So yeah, you cannot predict their properties based upon their valence electrons. Is really what it comes down to.
Sure. It's not as cut and dry.
No, it's not. Just because it's got 2 doesn't mean it's going to behave like somebody else has got 2. It's weird. They're least reactive, which is really fortunate for us married men who are wearing gold wedding rings.
Right.
My gold wedding ring is from the transition metals, and for that reason, it doesn't tarnish. It doesn't react with anything.
Yeah. Some of them don't react at all. Some of them react more.
And it's pure and shiny. It stays shiny. It's really useful for jewelry and stuff like that.
But I wouldn't say any of them react more than like the alkalis. The alkali metals are going to react more.
Iron rusts and it reacts pretty well, and that's in
but
the
it's not as like
metals.
fabulously violent.
No, not unless you mix it with aluminum and light it on fire.
Oh, let's try that.
No.
Moving on. Group 17 is the halogens family. This is a name we need to know.
Wait. We seem to skip group 13, 14, 15.
The BCNO group?
Yeah.
Why do we do that?
Well, because we're going to see later on that group actually is kind of more like a hybrid, boron, carbon, nitrogen, oxygen. Those groups, while they have the same valence electrons, their properties change from top to bottom.
Right, because in that group there are metals and nonmetals in the same group.
Right. They're in the same family, but they are both metals and nonmetals. So we're going to skip 13, 14, 15, 16, and go straight to the next group that has a proper name.
Right. It does. Not only does it have a proper name, now we get some things that are all in common all the way down the group.
Okay.
7 valence electrons. Notice the 17 ends in 7.
Right.
So one way to remember, other than looking it up.
Look at 7, yeah. These all like to gain an electron to become ions with a -1 charge. So while they have multiple selected oxidation states, they could do other things. They all prefer primarily to gain just 1 electron, which is why on our periodic tables, the selected oxidation states are listed in terms of probability. The top one is the most common one, and each one of these halogens has a -1 in the top right corner.
Yep. They form salts and compounds called halides.
Which you used to work with at Kodak.
Absolutely. Silver halide.
It's the reason why film could be film, especially black and white.
Yep. Reacts with light, and then it changes, and then that ends up being data.
So you mean that these halogens are reactive then?
They can be, yes.
So they react with light? That's pretty cool.
Yeah.
There we are, the most reactive nonmetals, fluorine. You actually brush your teeth with a fluoride toothpaste each night, which contains a reacted version of fluorine after it's done its whole electron grab.
We used to use hydrofluoric acid to digest metals.
That's the strongest stuff there is.
That I can think of. It will eat through the tabletop. When it falls through the tabletop, it'll land on the floor.
But it won't work. But it won't eat through plastic.
Yeah, a certain kind of plastic. It'll eat through glass.
Really?
Yeah, it needs like a special kind of polymer to hold it. Yeah.
I'm assuming that our students are going to ask to see that stuff.
And I'm going to tell them honestly, I can't get my hands on it in this building because we don't have the right safety equipment to contain it. I can tell you the one time we had an accident with it at Kodak, and it started to eat through the sink that was specially designed to hold it, where we could rinse it.
Panic!
And when it started to eat through the sink, they literally had to shut down the whole building, evacuate the building. All the fire trucks had to come. It was hazmat. It was crazy. But yeah, it's reactive.
How do you stop something that reacts with everything?
Yeah, right.
So everything in group 17 is now a nonmetal. So up until this point, every group on the periodic table has contained at least one metallic element. Shiny, conducts electricity and heat, all that stuff. But group 17 is where we fully get to the beginning of the end, so to speak. And nothing in that family acts like a metal.
Yep, it's all nonmetals.
The ones towards the bottom of the group are the most metallic, but
Right, right.
not
That's
really
just
a
in
metal.
properties. And then the other interesting thing about this, and this is sometimes that there on the is a part one question,
Yeah.
which family has all three phases of matter in it, and they
This
do
is it.
have a solid, a liquid, and a gas.
And it goes from the bottom to the top.
Yeah,
The
can we
solid
just-
is the iodine.
right, and
Those
isn't
are
the
a nice purple crystal.
and isn't the liquid bromine?
Yep, bromine's a liquid. Bromine is in as a liquid is in like your Mountain Dews and stuff like that as a preservative.
Okay.
Brominated
And then
vegetable
fluorine,
oil.
fluorine
Chlorine and fluorine
are my gases.
are gases. Chlorine was a gas used in World War One.
Yeah, mustard gas, right?
No, mustard gas is a different gas, but chlorine gas itself was used in World War One as a, biological agent almost.
Sure.
It is so reactive, it steals electrons. The chlorine gas goes out across the battlefield. The soldiers would breathe it in. It would react with the water inside their lungs to make acid inside your lungs, which would then eat your lungs from the inside out.
And then you
You're
can't
choking, can't breathe, and you suffocate. A very horrible way to die.
Ooh.
Which is why biological and chemical weapons are illegal.
Inhumane, really.
Inhumane.
Right?
They're
Right.
against human rights, so nobody's allowed to use
You
them.
gotta love these tangents on these videos.
Yeah, we got to get our nerd out
All
somewhere.
right, noble gases. Group 18, noble gases. I think of the nobility class, and the kings and queens do not like to react with the peasants.
I don't mix with anybody. I'm going to be off by myself in my big castle, sitting up
Yep.
there saying, "Go away, all yous."
Yep.
I don't want to deal with you.
Inert is a scientific word for unreactive.
Right. Every single one of them except for helium, have 8 electrons in their outside shell. That magic number 8, octet, 8 is great, is the reason why they are not reactive.
Sure,
that is
they don't-
considered in quantum nature's full.
Right, they don't want to gain an electron,
And they don't want to lose it
and
neither.
they're going to defend it. Right, they definitely don't want to lose it. So there's the exception, of course, is helium, because helium, having only that s orbital, can't hold more than 2 electrons.
So it's full.
He's
with helium.
considered full. Right, even though he doesn't have 8. He's the only.
These are the most stable. They exist alone in nature,
That's
and
noble.
they're super not reactive. So as a matter of fact, these are some of the last elements to be discovered because they don't form compounds.
Right.
They don't show up very easily on a spectroscope.
Right.
Not
It's a lot
that-
easier when they react and you see something
Oh, look at
happening.
this.
And
They
you know
must
that
have
there's something
in
there.
Yeah,
Right.
but when they don't, they're the last to be discovered.
And just to bang it home, right? Everybody wants to be noble gas and have 8 electrons. Remember, 8 is great.
Yep. Everybody wants to look like a noble gas. The 8 electrons. Now
This is your gig, man.
I love these lanthanides and actinides series. These are also sometimes referred to as the rare earth metals, not because they are rare, but because they are present in all the rocks on our planet in such low quantities that it's next to impossible to actually get a pure chunk of them. They're on the 2 rows of the bottom table. They're detached. The periodic table, if it were to contain these where they belong, would be twice as long.
Right. So
They
really,
kind of
if
did
you
that
look,
microscope view,
Right.
kind of chopped out and pulled them out
yeah,
below.
you can see that it even tries to show you with the big bolded line.
I think
and
this was called an orthographic projection.
oh, very nice.
Actually belong to the transition metals. These are the things that contain uranium, plutonium, and all the other elements that
Yep.
are only really made in particle physics.
Right,
which
and
are
you just
flesh.
probably mentioned the 2 that you're only going to ever see.
Uranium is U,
You know,
and plutonium is
Pu.
Pu. Oh, Pu.
Right. And the only thing that's really kind of a drag about these is they're not on table S on the back.
Yeah, because table S stops at 89.
It
So,
just skips them altogether.
There
So
you go. The names of them, yeah. 'Cause
Right.
They're again.
now here's the oddball of the whole thing.
Uh-huh.
Hydrogen
It's the one that's out of place.
Right. He's really not officially a part of anybody. Now, hydrogen and helium are both detached and kind of floating, if you will.
Mhm.
But hydrogen is really the guy that is the most.
It's the first element in the universe.
He really
It was
doesn't
the
even
first
know,
element
'cause,
created after the Big Bang.
It's
not sure if
he's
it's
considered a non-metal. He's considered sometimes he acts like a metal though. He's a gas.
Let's put it this way: hydrogen is so simple that it's super flexible.
Serious. That's a good way to put it.
Hydrogen
really
is
is
so
simple.
simple. It's one proton,
One
one electron,
electron, no neutrons.
maybe a neutron if it's an isotope,
Right,
or
maybe.
2. I mean, there are 3 isotopes of hydrogen.
There are, but the bulk of them don't even have a night or a neutron. So
Well, hydrogen 1,
No.
99.9999% of the stuff in the universe that's hydrogen is hydrogen 1.
one proton, one electron.
Period. End of
As
story.
simple as it gets.
So, it is a diatomic element, and so you can find it as H2 in a gas. But you can also find it in acids and bases as H plus aqueous, or
H minus.
H minus is
Well,
another
this-
really weird way of showing that.
Yeah, well, it's
acid-base
because
syncing.
sometimes it acts like a metal and sometimes it doesn't, depending on who it's hooking up with.
It's so simple that it can't decide what it is.
Right?
That's
Okay.
what it is.
But you know what it does do? Boom!
When the gas is reacted with oxygen, yes,
Right.
because it makes H2O.
What was the name of the blimp again?
This is Hindenburg.
The Hindenburg.
Der Hindenburg in the 1930s, the Germans had the Zeppelin fleet, and helium was too expensive to fill the balloons with. So they used hydrogen gas, very light, very low density, very good buoyancy, very explosive. And
Uh-oh.
you could not smoke the cigars on the blimp. The blimp and the crash in the.
Oh boy. Well, guess what? The long video's done. Now we know
Yep.
the different families. We know where they are.
And which elements are in them.
Yep. We just gotta, we're gonna have to have some practice on this and get them straight.
For sure. Fluency.
Fluency would be good, and retention.
Fluency. Retain as you gain.
Here we go.
See ya.
Good seeing you guys.